There are a lot of technologies these days, like cameras and so on, that everybody's using, but part of that mix is optics. And you guys at
Myrias Optics.
Myrias Optics do a lot of this. So can you tell us a little bit about what we're going to be taking a look at?
Sure. So Myrias Optics is introducing a novel approach to making a new type of optics. So we use a proprietary all-inorganic nanoimprint process. This is making optics on wafers, like semiconductor processing. And we design and develop lenses and optics using diffractive properties, which are referred to as flat optics or metaoptics.
All right, well, let's take a closer look at it.
So what we're demonstrating here today is an example device that can be made using the all-inorganic nanoimprinting. This is a project that we're working with one of our investors and customers, Asia Optical. This is a dot projector. If you have an iPhone, you have a system similar to this. It is operating in the infrared range of the optic spectrum, so you can't see it with your naked eye. But as I put my hand behind the projector here, you can see the dot pattern and how it's projected onto my hand. This is a device that's used to get 3D sensing or map your face. One of the advantages, or a number of the advantages with the device that we've built here in comparison to what's in the iPhone now, is we've compressed multiple optics down into a single device, so it's a much simpler system to build. We have higher view angle, better contrast ratio, all in a device that is less expensive to manufacture. The device here is manufactured or is amenable to manufacturing a range of different types of devices. We have a wafer here. This is a 200 millimeter quartz wafer, which has 8 devices on it. These are all individual eyepieces that would be used in a AR headset. We bring significant advantages here in terms of higher refractive index, which to the consumer means better view angle and better viewing performance out of the device. We can make a range of different devices. The way these are fabricated is we start with a silicon master. We create a flexible stamp like this device here, and then we use this to imprint the structures onto the wafer. The advantages of this are we can make a wafer like this every 4 minutes. So very fast, effective additive manufacturing. And then we're showing a range of different types of devices on this. Such as the dot projectors like I showed you here. We have various lenses, holograms, and grading devices like the AR waveguide that I showed you.
So that was some very interesting technology. In terms of implementation and availability, how would somebody go about working with you on this?
Yeah, so we try and be a full service provider for Metaoptics. We have design capability. We can build the masters, which are required to do the imprinting. And then, of course, we have the manufacturing infrastructure to deliver devices. So currently, Myrias will provide the design surfaces, the optics. We can singulate or provide wafer-level optics, depending on what the customer needs.
Okay. Now, what are some of the application spaces for this? You mentioned some, but there are a lot of areas where this could be utilized.
Correct. So we're very excited about the different opportunities and places that we're moving into. Everyone understands and is excited about AI these days. It's driving a lot of markets. Fortunately, we are the backbone or the picks and shovel model of AI. We provide optics for the interconnects that are powering or transmitting all the data in data centers. We are making the AR waveguides that go into your AR headsets to transmit that information to the customer. We make sensors and imaging systems that all allow consumer electronics or industrial systems to collect all that information which is being used. So any place that you see optics, optical sensors are great applications for Myrias.